before getting into functions, we first have to understand the definition of a relation. And so a relation is any set of ordered pairs xy. So this could be as many as one or two ordered pairs, it could be an infinite set of ordered pairs, and there's really no rules that those ordered pairs have to follow. They can be stacked on top of each other, they can be in a vertical, a horizontal line, they can be in a circle, a curved line, it can be anything. And so we have a lot of interchangeable terms that we can use to describe elements of a relation. So first of all, the domain, we know, hopefully, is the set of the inputs to that relation. It's the x-coordinates, if we're talking about it in the context of a graph, or if we're talking about it in the context of a equation, it's the independent variable. It's the variable into which we'll plug values in. And then the range is going to be the outputs, so the results of whatever inputs we plugged in. It's going to be the y-coordinates on a graph. And we call it the dependent variable in the equation because it depends on what we plugged into the function as to what our outputs are going to be, what the y values are going to be. So there are lots of ways, and we'll talk about more of them later, that we can represent a function or a relation. And one of those options is in what we see in front of us, a mapping diagram. And so a mapping diagram is just a visual representation of a collection of inputs and outputs of ordered pairs. And so essentially over here we have our domain, and then in the second bubble we have the range, and so we just have these arrows that are showing how the various values in the domain connect to the values in the range. And so they describe a set of ordered pairs. Each arrow is an ordered pair. So we have 2, 1, we have 2, 3, and then we have 4, 5. Now a function is a special type of relation. It's one where, as the definition says, every member of the domain maps to only one number in the range. Or the basic take home from that is every input can only be used once. Every input can only have one output. So if we go back to the previous example, we can see that 2 was used twice as an input, and so therefore it is not a function. Whereas in this next example here, our ordered pairs are 4, 1, we have 5, 2, and then we have 6, 2. And so although we're reusing the same output a couple of times, that's fine. As long as we don't reuse the same input multiple times, then that satisfies the definition of a function. In the second example we see in front of us, we have the ordered pairs 4, 0, 4, 1, and 5, 1. And so here we're reusing the 4 as an input multiple times, and so that means this relation being described by this mapping diagram is not a function. Now there are 4 primary ways that we could describe or represent a function. The first is verbally. We can be given a statement that describes the input-output relationship. It can be numerically, which is where we're given a list of ordered pairs and our function is defined that way. It can be done graphically, where we have a picture of a graph of some sort of set of ordered pairs, whether it's a line where there's an infinite number of ordered pairs or a set of discrete points. And so then we can see the points laid out that way for us. And then there's algebraically, where there's an equation with 2 variables, x and y, an input and an output variable, and we use that to define a function. So we've got these 4 options, and we'll be using all of these, although most of our space is going to be in these last 2, where we're going to be analyzing graphs, or looking at equations, or some combination of those 2. So if we want to determine if a graph of some set of ordered pairs, if a graphical relation satisfies the definition of being a function, we have a way of checking to see if we have repeat inputs through a graphical process, which is called the vertical line test. And so to determine if a graph is a function, we check to see if we can hit the graph more than once with the same vertical line. If at any point we can, then that means it is not a function. And because that just means that the same input has multiple outputs. The same x-coordinate has multiple y-coordinates. So on this first one here, I try, and there's no chance that I'm ever going to be able to hit that diagonal line twice with the same vertical line. So this one is a function. In the second example, with a vertically oriented parabola, I can try, but I can never hit the graph twice with the same vertical line. So that means every input, every x-coordinate, only ever has one y-coordinate. So this one also is a function. But in the last graph, we can definitely hit the graph multiple times with the same vertical line. And so if we look at the y-axis in particular, so we've got these three locations where we're going to make contact with the graph with the same vertical line. And so if we look at what are the ordered pairs in this circumstance, we have 0, 2, we have 0, 0, and we have 0, negative 2. And so what you can see is we're reusing the same input over and over again and generating different outputs. And so this does not satisfy the definition of a function. We're only allowed to use each input once. We can only have one output for every input. So that's why this last one is not a function. So the key here is that we understand that the vertical line test is not something different or separate from the main definition of a function. It's just a graphical test to see if any inputs are being repeated.